Hello, and welcome to another episode of the .NET Show. In this episode, we're going to deal with Visual Studio.NET, actually diving under the covers and illustrating some of the capabilities of debugging applications that are available with Visual Studio.NET. And not just debugging a standard client-side application, but debugging a distributed application through ASP.NET. But first, let's check in with Erica and the news.
Hello, I'm Erica Wiechers. Welcome to the MSDN News Update. On January 15th, Microsoft released the RTM version of Visual Studio.NET, the final release of the .NET Framework SDK, and version 1.0 of the Microsoft Mobile Internet Toolkit. These contain server-side technology that enables ASP.NET to deliver markup for a wide variety of mobile devices. In other launch news, coinciding with the street release of Visual Studio.NET in mid-February, the Visual Studio, Visual Basic, C#, and C++ websites were redesigned and feature new content, information, architecture, and UI. MSDN Online also geared up for the release of the .NET Framework SDK and Visual Studio.NET through their .NET 6-Week Series Guide. The guide offers a weekly focus on a specific aspect of .NET development supported by articles, samples, how-tos, chats, and webcasts. Some of the weekly themes include smart client applications, XML web services, and enterprise development. In early February in Los Angeles, Microsoft sponsored the Blacks in Technology Summit, the nation's first free consumer and business technology exchange for African Americans. The focus of the summit was to bring together technology experts and showcase technology solutions for African Americans at school, at work, and in the home. The summit is scheduled to take place in Atlanta, Chicago, and New York in the coming months. In mid-February, Microsoft released a UML to XML export component that works with Visual Studio.NET Enterprise Architect and Visio 2002 Professional. This component allows you to convert a UML model created in Visio to an XML file compliant with the standard XML schema. This makes the data available for any application that leverages the power of XML. The component is now available to download from MSDN. This has been the MSDN News Update. I'm Erica Wiechers.
Welcome back. Like I mentioned earlier, today's episode we're going to be talking about debugging applications, specifically using Visual Studio.NET and addressing some of those key aspects that are unique to applications written for the .NET platform and using ASP.NET, WinForms, as well as web forms. And here to talk to me about some of those topics and help you understand what debugging means using Visual Studio.NET, I have Shaykat and Habib. Thanks for joining us.
Thank you.
Debugging is something that a lot of developers need to focus on when they're writing applications. How exactly is the .NET platform different in that respect, and what does it bring different to the table?
Well, the .NET platform essentially is a totally new platform that we developed over the last couple of years. So to start with, right, we didn't have a debugging environment for it like 4 years ago. So Visual Studio.NET essentially tried to capture the experience that developers had for C++ and for VB inside of for the .NET platform itself. There are several cool features of the .NET platform which help in debugging. Some of the things that are built into the APIs itself is like the tracing and diagnostic tools features it has. ASP.NET also has some very cool tracing features which Habib can describe. There are several cool things inside of it that go towards debugging, but also we've also tried to make it as much as C++ as possible.
One of the most important things to remember is that even though we have a brand new platform, we made sure that you can use and leverage the same existing knowledge in the actual when you're debugging your .NET application. So that, for example, if you had a VB6 application and you were debugging that, we wanted to make sure that you can transfer that knowledge over to Visual Studio.NET and, for example, debug your Windows Form application just as you debug your forms in VB6, basically. So
from the user side of things, everything looks very similar, they're comfortable with, but underneath the covers, you've had to change quite a bit in order to focus on the new .NET platform.
Absolutely. We wanted to make sure, even though the actual architecture underneath is quite different. But in terms of user experience, we wanted to make sure that you had the same experience as you had in either Visual Basic 6 or Visual C++ 6. The other thing to remember is that we actually usually receive a lot of requests in terms of I want to have a single debugging experience, no matter whether I'm debugging my VB6 application or C++ application. And in the new Visual Studio .NET debugger, we actually integrated the whole shell into one, so that no matter whether you're debugging your C++ application or your VB.NET application or your Visual C# .NET application, you have the same exact tools and experience. So it's actually quite easy to, let's say, debug from one application to the other.
Now, a lot of that comes out of the benefit of the CLR itself and providing a single language model that everyone's focusing on. Does that provide Visual Studio.NET some benefits of that single model, or does it even make things more difficult for designing the debugging model? I mean, because suddenly you've now got this setup where it doesn't matter whether it's C# or C++ or VB.NET, the CLR is the same, and now you're debugging against that. But to get back to the original language, isn't that kind of difficult, though?
Well, actually, essentially what we do is that because when you actually compile, let's say, a Visual C++ .NET application or VB.NET application, there is actually MSIL generated. So that's Microsoft Intermediate Language. So in terms of the underlying actual metadata or the actual DLL itself, the debugger treats it no matter, it's exactly the same. It's actually, it's what the actual developer is comfortable with, the language that they're comfortable with, as well as the actual different language idioms that they're comfortable with in debugging and writing code with.
Right. And to follow with that, so as all these languages target the common language runtime, we essentially have one debug engine for all these languages. So we even have third parties who can target the CLR, and our debug engine would be able to debug their languages. So languages not developed at Microsoft could be debugged using Visual Studio. Additionally, we've also done work to have people be able to debug COM components, like C++ components, that they call from the runtime, and vice versa as well. And in this case, it took quite a bit of work and some excellent dev work to actually make this what we call interrupt debugging, where you debug some managed code and then you seamlessly step into the native code to make that work in Visual Studio, actually. And that's one of the added benefits you get when you use Visual Studio to debug your applications, because we see developers as having old COM legacy components, and not everyone is going to start moving everything into managed code tomorrow. They're still going to want to use some of their applications, and Visual Studio.NET is a really cool tool in this case to step from some managed components that you have into old native C++ stuff.
Mm-hmm. Plus, also being able to take and so you combine multiple languages in DLLs and stuff like that in an application. I'm assuming you can take and bounce from a C# application to a VB.NET DLL to an unmanaged COM component or something like that, and you're still within the same environment that whole time.
Exactly.
It's actually quite amazing when we actually demonstrate this to developers. It's like, wow, I can step, let's say, from my C# Windows form into a VB.NET web service into, let's say, a SQL stored procedure, and it's actually quite amazing.
Into a SQL stored procedure as well?
Yes, absolutely.
Because that's not CLR. It's not even regular unmanaged code. It's something totally different.
Absolutely, and I'll demo that sometime in the actual second half of the talk. But we actually made sure that you have a single integrated debugging experience, no matter what type of application you're developing, being a Windows form or a distributed web service-based application.
Just to recap for the camera, Visual Studio.NET debugger rocks. There's no two ways around it.
You obviously feel pretty passionate about your product. That's good.
It's funny, right? Like I showed the demo I showed it at PDC, right, where you step between different languages, and people went crazy. And then I showed them debugging into T-SQL, which is not something that people know about. And I mean, the crowd just went wild. I mean, you'd be amazed at how much people really appreciate knowing all the cool features that they can do. And, it's really enjoyable actually telling people, you can do this. And people go, wow, and they think you're awesome for some reason. It's like, no, I just bring the knowledge to you guys, that's all.
It's actually the devs who do all the work,
that's
and
true.
then the program managers are the ones that
get all the glory for it.
Yeah, exactly. We like it that way also, just to be.
Now, with .NET is very focused on a internet distributed sort of model. That's kind of different for debugging applications. Usually when I debug an application, it's like, source code that I wrote that's running on the machine I'm running it on, and the XE's right there in front of me. I can grab it, touch it, delete it, whatever I want to do. Where the distributed app, web services, ASP.NET, stuff like that, that's running on some other system out there. Where do you debug that from? How do you debug that using VS.NET?
So with Visual Studio, well, one of the big things that we did for this release was to make ASP.NET debugging a lot easier than ASP, especially remote debugging. One of the other features is that for every language that we support, we allow you to remotely attach across machines and to a process and be able to debug it. With web services, for example, to Visual Studio, to the debugger, it's essentially just a DLL that gets loaded up inside of a process. You can debug multiple processes at the same time. This was not something you could do in the past. With Visual Studio, there are several ways to debug web services, and some we made very easy for developers who know exactly where their processes live. And there are others also where you can just, at the worst case, you can just do a manual attach to a process. Given the fact that you have the right permissions and the right components on the remote machine, you can manually attach to it, set a breakpoint in your code, and hit it and debug away.
Just to recap on that, it was actually a goal of ours so that it doesn't matter if, let's say, your components are on a remote machine in terms of a web service, you still have the same debugging experience. There isn't a complicated setup involved, or you don't have to actually change a lot of the actual ways that you debug your normal applications. It's actually the same no matter whether you're debugging a local application or an application on a remote machine.
So you don't even have to be running on the server. You don't have to be sitting back in the back room running on the server doing the debugging. You can actually be debugging from a client machine off on the internet somewhere.
Absolutely.
In the comfort of your own home.
Yeah. Well,
so yes, you can do that.
What do you see as some of the key problems that people face as they're developing applications and need to get started debugging? Because debugging can be kind of this strange art. I mean, everyone can write some VB.NET code and write some C# code or something like that, but actually thinking about debugging it and setting breakpoints and setting watch points and stuff like that, they kind of say, oh, that's different. I can't handle that. What do you think are some of the problems people face, and how does VS.NET help solve those?
Well, I guess the old printf statement, which I think just about every developer is used to, basically, that only goes so far. I mean, in terms of, let's say, if you have distributed application, that just won't work. Now, in Visual Studio.NET, we've made sure that, for example, if you just want to start up your application and set a breakpoint in a, let's say, ASP.NET web form, it's actually very, very trivial. It's very much like how you did in VB6. Set the actual red glyph in the gray margin, and then off you go. And also, the actual .NET framework provides a very nice set of APIs, which I'll show you later on, where you can instrument and also add tracing statements to your code, so that you don't have to deal with like various different forms of asserts like you had to in, for example, Visual C++6. So it's actually, again, because the environment is so similar, I guess, in many forms to what you had in VB6 or Visual C++6, the actual tasks that you have to debug your applications are the same. And the kind of problems that you come across are, for example, if there's an unhandled exception, or, for example, if you're making a call to a web service and it times out or you get the wrong results back, Visual Studio.NET helps you to debug all those different scenarios. So we've made sure that you can do all those tasks.
Also, as just a side note, I know because when I first started out here, I was a printf debugger. I would put printfs all over, and I'd take my code. And it was almost a step for me, and partly because I work on the debugger, to actually learn how to use the IDE itself to debug code. But once you do that, and the more I got to know about the debugger itself, the more powerful was the actual techniques I could apply to figuring out what my problems was. And Visual Studio.NET, like almost every day, you discover something new that you can do. We have a joke. No, we don't have a joke, but like every now and then our C++ developers joke that they have this old code base, and they say that, oh, we'll be looking through the code base someday and we'll find, oh, what does this expression do? And they'll type it into the watch window and they'll see, oh, wow, I can see, the number of handles I have accessed. And, it's just something new pops up. But I think it's very important for developers to also put time into learning the tool. The more you know about the tool, the better your techniques can become to debugging it. Things like the exceptions window, things like the breakpoints dialog that we provide, things like the processes window. It's good to put some time into learning the tool so that when you actually are faced with a problem, you have a wide variety of techniques to deal with the problem. Also, there are several good books out there. The last time I checked on Amazon, there were like 100 books on debugging techniques alone. And, it's just good to educate yourself on the actual art and educate yourself on the tool. Because, you'll be probably spending like a good 50% of your time debugging anyway. And better to do it right than with just printf statements.
Absolutely.
So part of the programming challenge is not just knowing the language, but actually knowing the tool you're using for developing the application.
Absolutely.
Right. And some theory behind what you really should be doing.
Yes.
Okay. Yeah. Well, I think it sounds like we've got a lot of demos to show and stuff like that. So I think probably the best to get onto that and stop jabbering about the architecture and let's show some screenshots.
Absolutely.
Awesome. So after this short break, we'll be right back, and we'll show you some actual demo code, how you can develop applications and debug them using VisualStudio.net.
After months, and in the case of VisualStudio.net, years of development time, Microsoft likes to celebrate with ship parties. The diversionary tactics that you're about to see is a video that was shown to internals at the recent .NET Framework ship party. Enjoy.
Hey, congratulations, .NET Development Platform, for shipping the next greatest development platform.
I'd like to thank everyone for all the hard work throughout the entire 3 or for some teams 4 years.
Unbelievable! It may have taken us a little while longer than we wanted, but good things take time and effort and energy and just unbelievable brain power.
I talk to a lot of customers, as do you, and they always wonder, how does the software methodology at Microsoft really work?
5 years ago, we had a dream that applications would not be judged by the syntax of their language, but by the quality of their execution.
Well, I did some studying, and this is what I've come up with.
We have seen the mountaintop. I may not have gotten there with you, but you have realized the dream.
All right, now you always remember the beginning of every release.
What's the official name of the group?
Where did we go from there after we had the original design teams for the SDK?
I think after Project 42 we did, we were Complex 2.0 next. That's what I remember anyway.
No. We were URT next.
No, you are so smoking crack.
Then you kind of move into this next phase where we didn't really promise that, or maybe that's not going to work, or we should start to think about cutting features.
Wow, hits. I'm not quite sure how to react.
I remember the first day that I moved into Building 42, there was a giant banner in the lobby, and it said,
These are actual real shipping bits.
"Those who ship win."
It's not Tech Preview 49,
That's not quite right.
Beta 15.
What it really is that those who ship great software that meets customer demands win.
You're not pulling my leg, are you?
Project 42, then URT, and then Complex 2.0, and then after that we were the .NET Framework?
Yes.
There's 3 kinds of people in the world. There's people that already know that Visual Studio.net and .NET Frameworks are the best. There are people that are going to know soon, and there are people that are stupid.
I can't remember, was the Universal Runtime, was that our group name?
This thing should have been 2 releases from the beginning, right? Remember that? This is where all the chickens quit. None of you guys are the chickens because you stuck with it, right?
52 bottles of beer on the wall.
Hey, at least the builds are working. Remember that quote?
NDP admins rule.
Amen.
We're test complete now. And the bugs don't look too bad, because we just got test complete.
I'm looking at the stress failure, and it looks like there's a problem in the large object GC keep. Can you look at the line 11436 carefully? We are not protecting one large object. There's something I don't understand there. I haven't thought of that. Thanks. Hey, I find it! Thanks for all your help.
Not a problem. It's been our pleasure, Wei-Win. Thanks for calling the Larry Sue Psychic Hotline.
I think I can expect a call from Mike Stanton soon.
How long can this bleep go on?
And I remember something about the ASP.NET team way back in the beginning. There was a code name, I think.
Oh yeah. Wasn't it duct tape?
No, that wasn't it at all. The code name for ASP.NET was XSP. Duct tape was the code name for HTTP.sys, which is the kernel mode WebDriver. And we came up with that name because there was a certain employee who, when we're having the meeting, could not keep himself quiet, and somebody joked that we needed to get the duct tape out to
Actually, duct tape was not named after HTTPCs. It was named after ULCs. The HTTPCs came a long time afterwards.
Whatever.
See how simple that is?
I don't know why people get confused over that.
So you've gotten through all that. You've hit Euphoria. You've made a new round of T-shirts. And my congratulations to each and every one of you. Fantastic release. That I think you're going to change the world with this. And my absolute congratulations to each and every one of you.
Great engineering from beginning to end. I want to thank you. Have a great time. And let's get on to the next product.
It's all about the developer. It's all about the apps. The server is about the apps. It's about the apps. God dang it.
So thank you for helping me with the apps and helping me sell servers. And Treadwell, even though I've never said this before, I love you, man.
Congratulations on a job well done.
For something like debugging applications, it's obviously extremely important to spend a lot of time working with the tools and showing you what goes on behind the scenes and stuff like that. So I've reserved hopefully enough time now that we can actually dive into what VisualStudio.net does and how it allows you to debug applications better. Joining me again, I have Habib. He's going to take and show us how VisualStudio.net allows you to debug applications using the .NET framework. Thanks, Habib.
Thank you. Basically, what I've done for this demo session is that I have a number of projects, different types of projects, for example, like an ASP.NET web service or a WinForm, that I'd like to show you how to debug those different types of applications. The first thing that we want to do is that it's important to actually familiarize ourselves with how the VisualStudio.net debugger kind of works, I guess, and where all different commands and tools are. So what we have here is the actual VisualStudio.net IDE. Essentially, you will be able, once we actually load up the project, you'll be able to access most of the commands from the menu bar itself. So why don't we go ahead and right now and open up a new project. This is actually the canonical math web service that I think just about every demo uses, and I'll go ahead and use the same demo application. So as you can see right now, when I actually opened up the project, now I have the various debugging options available from the debug menu, as well as being able to do various execution controls such as step into or step over. I have various windows currently, but there are actually more once you start debugging. So I can either launch the breakpoints window or the immediate window. So why don't we just go ahead and actually look at what this web service does without even debugging it, so we get a feel for how the application works. So I'll go ahead and actually start the application without actually debugging it right now. This will go ahead right now and just launches the application in Internet Explorer. This is actually an ASP.NET web service, what we call test page. So this is generated automatically for you, so you can test your web methods without having to write like a test harness, I guess. It's a really nice tool to actually get to play around with your web methods.
So what you've written here basically is a web service.
Yes.
That's doing an add and subtract.
Exactly. That's simply it. And I'll show you later on what the actual code looks like. It's extremely simple, and we'll look at that a bit further down the road. So just to show you, it's a very, very simple math web service. So all I want to do is basically add two numbers, for example, 1 plus 1. And when I invoke this, you'll notice that we actually get back the result of 2, which is what we, of course, expected. Now, the question is, now I want to actually debug this web service. How do I do it? So let me just go ahead and actually close the Internet Explorer session that we had before. It's extremely simple. Again, if you remember from the previous talk that we had, we wanted to make sure that the actual debugging experience is very similar to what you have in basically client application. So in this case, if we look at the actual source code for the web service itself, let me just make some room here so you can see what is going on. I have two web methods, as you can see. I have the add web method and the subtract web method. What I would like to do right now is debug the add web method. Again, it's a very, very simple method, but it's just the actual technique of debugging it. So all you need to do is simply left click on the actual gray margin itself and then simply launch the application. So again, I'll start the application this time. So what's actually happening underneath is that we're attaching to the ASP.NET Worker process, which we call the ASP.NET_WP process. So actually, if I can go ahead and show you in the task list itself, once the actual task manager brings up, you'll notice in the actual processes dialog, there's the actual ASP.NET_WP process, and I'll show you later on when you actually need to manually attach to an ASP.NET web service or web application, you need to attach to that process.
Because that's what the debugger is going to be looking at for gaining access to the web service.
Exactly. The actual web service or web application runs within that process, so you need to attach to that process itself. So I'll go ahead and actually close this dialog right now. So what we wanted to do is actually debug the add web method, and I believe if we haven't timed out yet, we should actually break into the debugger. And as you can see right now, we're broken into the debugger right now, and the breakpoint is hit where you set it before. Mm-hmm. Now, let's have a quick look at the various tools that you have available right now. We have the autos window, which basically displays the statements which are near where you set your breakpoint. So in this case, as you can see, we have the actual parameters A and B. And of course, we have access to the this object, or if you're writing a VB.NET application, that's the me object basically in VB. This shows the actual local variables. And then, of course, you can set your watches. It's as simple as simply highlighting a variable. In this case, of course, you'll see the tooltip itself. And then simply dragging it onto the watch window, and you can actually watch the variable itself. Now, on the right-hand side of the actual pane, what you see is the actual call stack itself. This displays the actual sequence of calls that were made, which landed you at the actual add web method itself. We actually display all of the entire call stack for the frameworks as well.
So that's the call stack that it took to get to the web method on the server once the web page was called with the numbers added and the invoke
Absolutely,
command.
That's exactly correct, yes. So as you can also see is that there's actually a column called language, and we'll see later on why that is. It's basically because we can debug multiple languages, you can easily see, right now, this is what the actual call stack was and that's how it got there from various components. Of course, we have the breakpoints dialog, and that displays the actual your breakpoints. The command window, this is very similar to what you had in Visual Basic.NET 6 as the immediate window, where you can type in various commands and expressions and have them evaluated. And of course, the output window displays all the outputs that you display. So why don't we just go ahead and basically execute the rest of this. And and as you can see right now, we just completed a whole debug cycle of your add web method.
So if you'd had a bug where you weren't getting the right value or something like that back, you could have stopped at that breakpoint, looked at what the incoming values were, looked what the calculation was, stepped through a couple more lines before it came back to this point.
Absolutely, yes. So as you can see, it's actually very much how you would have debugged any other type of application in either Visual C++ 6 or VB6. So having seen how the actual, to debug the standalone web service itself, the question is, what if I wanted to consume this web service from a, let's say, ASP.NET web form? How would I go about debugging it from all the way through? So I want to make the call from my ASP.NET web form all the way through to my ASP.NET web service and be able to step basically into my web service from my ASP.NET web form. So if we actually go back to the start page, you'll see that I'll have the web form calc application. It's a very, very simple calculator, which essentially just uses this web service. So if I can just show you the UI, and unfortunately I'm not the best person to design UI, so please excuse me.
Programmers rarely are.
Yes, that's absolutely true. So, This is the fantastic web form calculator, as you can see. But the most important thing to note here is that we'll be debugging the add method, which actually calls into our web service right there. So why don't we go ahead and add the actual code for the add handler itself. I've cheated a bit, and I've actually previously have the code right here. So all I'm going to do is start basically dragging and dropping the code snippets that I had. This is actually a great feature of Visual Studio.NET, where if you have code snippets that you reuse all the time, it's very easy to pull it on your toolbox and then simply drag and drop without having to retype everything, basically.
Or if you want to do a demo, it works fairly good for doing
Absolutely, that's very true as well, yes. So for the first part is we want to look at the actual declarations itself. So let's declare some variables in this case. What we have here is we're actually taking the values from the two text boxes, text box number 1 and 2, and then basically converting them into integers. So, and the next step would be for us to actually call the web service itself. So I'm going to drag and drop the actual code from my toolbox onto the editor itself. So as you can see here, all I've done is I've basically instantiated the web service and called the add web method. The next thing that we would like to do is actually display the result as well. And it's very, very simple. All we're doing is simply putting the actual result in the text box. Now the question is, of course, I've gotten a bit ahead of myself, is I haven't actually added a reference to the web service itself. What I will need to do right now is go and actually add a web reference to the math web service. The way to do that is I'll just go ahead and right-click on my project and say Add Web Reference. Now, this should essentially display all the web services on my local host, and I should be able to access if I don't actually have that right now. So let me just go ahead and type in the actual, I believe it's Math Web Service. I believe it's math dot. If I've done this correctly right now, and I don't trust myself when I type things in, there we are right now. So all I have to do in this case is go ahead and add the web reference to my project. What this will do behind the scenes is generate the proxy from the actual WSDL file itself. And if you really wanted to, of course, you can dig into the various files and have a look at exactly what's happening underneath. So just to make this a bit nicer, I'm going to actually rename my web service from localhost to actually Math Web Service to give it a bit nicer name. Now, if I've done everything correctly right now, I should be able to simply set a breakpoint on the add button event handler and start debugging this, and all the way through to your web service call. So let's just see how that works right now. So I'm going to start debugging, and if I haven't made any syntactical errors, I should be able to have the... There we are. That's actually our ASP.NET web form. So let's just go ahead and do the same as before. We want to add two numbers, and I hit the add button. And again, I've hit the breakpoint. Now what I would like to do is I actually want to step through the code itself. So let's just go ahead and step. This is where I actually instantiate the Math Web Service itself. And now this is where the actual web service call gets made. So if I step into it right now, or if I hit the F11 key, I should be able to step into the web service itself. So let's just go ahead and see if that works. And as you can see right now, you're actually in the web service itself. And it's seamless, basically. Let me just go ahead and show you what the call stack looks like. So what you see currently here is the actual server-side call stack. These are the sequence of methods that were called on the server itself. But you ask yourself, what if I want to see the entire call stack going from my client all the way to the server? How do I go about doing that? It's actually a very neat feature that we have where we call it displaying a merged call stack. So if you check this, the include calls to from other threads, you'll see that there's actually a boundary right now. The dotted line is the boundary between your server side and your client side. So you can easily see what the sequence of calls were going from your ASP.NET web form to your ASP.NET web service. So again, you can see how seamless the actual experience is. Even though,
you see there, if we look at right above the add call down here,
right,
we have the SOAP HTTP client protocol. So you're taking that function call, converting it to a SOAP request, bundling that across HTTP headers,
yes,
passing it to the web, and then gets across on the server side, picks it up.
Absolutely, and then you can see on the reverse side, on the actual server side, it actually gets the SOAP request, unbundles it, and then marshals the parameters, and then you have your add web method call on the other side. So it's actually very neat. Of course, the web client in this case could have been a VB.NET application or a managed C++ application. That doesn't really matter. The debugger treats them all exactly the same.
Now, in this particular example, you're using localhost, which means that the machine, which is your client, also is being your server.
Yes.
What would the experience be like if you were really using a client machine and the server was off in the cloud somewhere?
Amazingly, we actually, it would be exactly the same. We've done a lot of work underneath to make sure, in this case, remote debugging is seamless, basically. So you will see the exact same call stack. Of course, you have to have the right permissions. We made sure that you have always, when you're debugging, you have the right permissions as well as security context to make sure your application is always secure while you're debugging. So.
And you'd have to have the source code project on your client machine, so that VB or Visual Studio Net could access the sources and show you the source level debugging like that.
Right. One of the actual features of Visual Studio Net debugger is that even if you can't find the sources, it will actually prompt you for the sources. So, for example, if your sources are somewhere else, it'll say, okay, where are the sources? Show me. And it actually gives you a dialog, and you can specify where the sources are. So, again, it's very, very easy if you've placed your sources somewhere else to access those while you're debugging.
Great.
Okay, so why don't I go ahead and actually stop this application right now. So I just showed you how simple it is to debug a standalone web service and also a web service called from a web form. We actually get the question quite a lot of, what if my web service was already running? How do I go about debugging that? And again, the actual process is very, very simple. So let me just go ahead and open up the web service project again that we had previously. So in this case, what I'm going to do is I'm going to actually launch the application, but without debugging it. Because what I'm going to show is how to manually attach to the ASP.NET process, and then we'll be able to do the exact same as in setting the breakpoints and being able to debug our web service. So I'll go ahead and launch the application right now, but without debugging it. Now, what I need to do in this case, this is assuming our ASP.NET web service was already running. I will go to the debug menu and look under the processes command. This will launch the processes dialog. What you see currently are all the processes running on your local machine. Of course, as I mentioned before, we also enable remote debugging. So if you really wanted to, this field, the actual name field, you can change it to any machine that you want, and then remotely see the processes on that machine and attach to those if you wanted to. So it's actually very convenient to do the same thing. It's as simple as changing the name. For example, if the machine name was Habib H2, I could simply type that in, and it'll show me all the processes on that remote machine. So what we want to do in this case is, again, as I mentioned before, this is the ASP.NET worker process that we want to attach to. So I simply go ahead and click the attach button. This will actually launch the attach to process dialog. Some of our users have complained that they're not sure exactly how to use this dialog or what it exactly means.
You just click on buttons and stuff like that, and it just works, right? Okay.
Yeah, usually that's exactly all you have to do. So what this dialog represents is that, again, as I mentioned before, the Visual Studio.NET debugger allows us to debug various types of languages and applications. So in this case, we have an application, for example, ASP.NET web service, which runs on the Common Language Runtime. Therefore, you want to actually debug it using the Common Language Runtime debug engine. Now, if you had Microsoft, if you had T-SQL store procedures, you actually want it then attached with the T-SQL debug engine as well, and so on, basically. Since in this case, we're only concerned with debugging the ASP.NET web service, which runs on the Common Language Runtime, all we have to do is just check the first box. That's all we need to do.
And if you'd left native checked there by default,
yes,
it still would have worked perfectly
absolutely. There will be no difference at all, basically. So I'll go ahead and click on that right now. And then, as you can see right now, the actual debug processes pane here on the lower part of the dialog shows you the current processes that are being debugged. One of the great features of Visual Studio.NET Debugger is that you can actually detach from the process without terminating the process itself. This is very useful for things like, let's say, long-running Windows services or ASP.NET Web Services, where you just detect a bug, attach to it, debug the code, and then detach from it, and the actual ASP.NET Web Service is still running. So in this case, if you really wanted to, of course, you could have chosen the second option, which is terminate the process. But in this case, we'll just leave it as it is, basically. So right now, we're attached to the process, to the ASP.NET Web Service. Again, it's as simple as setting a breakpoint and calling the web service again. The steps are very, there is actually no difference. It's seamless, basically. So as you can see, the actual experience is the same no matter how you actually start your debugging process, basically.
And so even though what we showed there was the calling of a basically static function,
right,
that could have been something that was actually running and doing stuff on the server while you're doing the attached process to it, and you were just basically calling into it from another process.
Exactly right. That's okay. So we just looked at various forms of how you debug an ASP.NET web service. Now the question comes, a lot of applications, especially like web applications, rely on data. Data is a very important part of your application. Of course, you want to be able to debug your data components as well. One of the great features of the debugger is that you can actually debug your your SQL stored procedures.
Yeah, we talked about that earlier. I mean, it seems kind of strange to be able to debug into SQL stored procedures like that.
Absolutely, that's the exact reaction that we usually get from the actual users as well. It's like, well, how do you guys actually do that? That's just it's SQL stored procedures. It's not really normal. I guess they call it normal code, but I'll show you how easy that actually is.
Of course, I guess the SQL guys would call it normal code, but we would.
That's true, but that's just different now. Okay, now. What I would like to do is I'll just go ahead and close the current solution right now. And in order to interact with your SQL stored procedures, a great tool that you want to use is the actual Server Explorer. It basically allows you to interact with various services on your machine. So in this case, I'm interested to actually use the SQL server services. You can also access your other, let's say, Windows services, performance counters, and so on. It's just an amazing array of tools right at your fingertips that you can integrate within your applications very easily. So what I've done in this case is I've created an instance of the database that I'm interested in. In this case, it's the actual Northwind database, which I'm sure many of our users should be familiar with.
Seen that far too many times.
Yes, exactly. So what we would like to do, first of all, is we just want to debug the SQL stored procedure on its own, without it being called from another application. So I just expanded the actual node itself, and under the stored procedures node, you'll notice that you can actually see all the stored procedures in that current database. What we're interested in, let's say, is the sales by category stored procedure. So if you right-click on that, you'll see that you have a number of options to actually interact with that SQL stored procedure. You can actually edit your SQL stored procedure right within the IDE itself. In this case, let's just go ahead. We just want to run the stored procedure to see what the results are. You can simply go ahead and run the stored procedure. And what this will actually ask you is that it'll ask you for the parameters. So the actual category name, let's just say seafood, and let's give the value of, I believe, if I remember correctly, 2,000. Okay. Now, if you actually look, the Visual Studio environment went ahead and executed your stored procedure within the IDE itself, and you can see the results of your stored procedures right within the IDE without having to go to any other tools, which makes the development experience that much more integrated without you having to learn different tools. It's all in one IDE. Now, the question is, now I want to actually debug the stored procedure. How do I go about doing that? So, again, all you have to do is simply right-click on the stored procedure. In this case, we want to actually step into it. And once we do that, you'll actually notice that it asks me for the same parameters. And now, you have the exact same tools as you had before. For example, you can actually step into, if this stored procedure was called another one, you can actually step into it further on. Also, you have access to the various watch and different tools that you have. Again, you have the normal call stack. So the experience is exactly as if you were debugging, I guess, normal code, if you will.
So does this mean that SQL is using the CLR, or does this mean that Visual Studio.NET has intentionally dived into the native format of SQL?
It's actually the latter part. It's the Visual Studio.NET environment being integrated with the actual SQL components that allow it to do that work, basically. So again, you can simply go ahead and run the rest of this application. And as previously, if I change to the database output pane, we have the same results that we had before. So the big question is, now this is part of my data components, and I've used this in my, let's say, ASP.NET web form. How do I go about debugging all the way through from, I found a bug somewhere, I'm not exactly sure where it is, so I'd like to be able to step through all the way through, and then ultimately step through my stored procedure. What I have here is that, let me just go ahead and auto-hide this window right there, and I can, I should have this, okay. I'm going to open up a new project from web, which is called SQL Debugging, I believe. Okay, now, let's just see how this works. I should be able, again, to simply set a breakpoint on the stored procedure and be able to call it from my ASP.NET web form. Again, the web form is extremely simple. All it does is you can select different categories and it'll call the stored procedure and it'll populate your data grid. So let's just go ahead and start debugging this. Now, what I would like to do is that when the user selects the actual category, I'd like to set a breakpoint on the actual event handler and start debugging from there. So let me go ahead and change the code view. Now, I should just mention, actually, with the current version of the Visual Studio.NET debugger, you can't actually step all the way through to your stored procedure. That's just the current limitation that we have that we're addressing in the next version of Visual Studio.NET. But basically, the way that you would debug it is that you set a breakpoint on your SQL stored procedure, and you run your, let's say, ASP.NET web form, which then hits the breakpoint. So in this case, since if we look at our actual breakpoints dialog, we'll see that I've already set a breakpoint on my stored procedure right there. So I won't need this breakpoint right there. Now, if this is all set up correctly, I should be able to hit the breakpoint in my stored procedure running from my ASP.NET web form. Let's see how that works, or whether that works. Let's just cross our fingers.
You have done this demo before, haven't you?
Well, yes. Okay. Now, the question is, why didn't my breakpoint get hit? The table was populated, but I should have hit the breakpoint. This is actually, I did this on purpose to show our users that this is something that our users come across quite frequently. In that you need to actually set a project setting to be able to enable stored procedure debugging. So why don't I go ahead and close this application right now and show you what needs to be done. So in your Solution Explorer, if you access the project properties, you'll notice that under the Configuration tab, there is a debugging page. There is a property called Enable SQL Debugging. And as you can see right now, that's set to false. What you need to essentially do is change that to true. And then hopefully now, when we start debugging it, we should be able to set the breakpoint.
And the reason you might want to leave that for false if you weren't really needing it was because I'm assuming that brings in some additional overhead.
Absolutely.
Right.
And we actually want to make sure that the debugging experience is as performant as possible, so that if you don't need the components while you're debugging, then the debugger shouldn't be loading those, basically. And that's the actual approach that we took. So why don't I go ahead and launch the application again, and hopefully this time, crossing fingers again, when I actually change the category, I should be able to hit the breakpoint. And again, you can simply step through this, and then get back what you had before. So as you can see, again, the interaction, no matter where you're debugging, no matter whether you're debugging a web service, an ASP.NET Web Form, or SQL Stored Procedures, it's all in the same integrated debugger, which is very, very useful because it means you can leverage your skills, basically. Now, one of the things that we paid particular attention to was that we know that our users have existing code. And as Shaykat mentioned in our previous talk, it's very common that most users won't immediately port all the code over to managed. So it's very important for our users to be able to debug their unmanaged code from their managed applications or vice versa. So we particularly made sure that that's actually possible in the debugger. If I go ahead and actually open up a project, in this case, I've called my application, it's actually, the scenario here is that you have an existing ATL, a COM object, and you want to make use of it in a C# Windows form. How do you go about debugging that? So why don't I go ahead and actually open up the solution itself. Again, please excuse my UI.
At least things line up pretty well.
Yeah, it's actually not. I think actually I can pat myself on the back. It doesn't look too bad, actually. The important thing to remember here is that what you see here is the ATM project, which is actually our C# Windows form, is actually a managed application. But if we look in the actual test ATL project, you'll notice our C++ developers that this is all pure COM. This is all native C++ code. And what I would like to do is I'd like to be able to make use of this code within my simple bank application, which is basically uses the account COM object that I created with my ATL.
So the basic concept here would be then, if you were a bank that had a lot of investment in the processing logic, DLLs and services like that and capabilities, you would now be using C# as just writing a front little wrapper for the front, doing the UI, attaching to those back-end COM objects.
Absolutely, absolutely. And we realized how important that is for our users, because there's a huge investment in existing code, and you want to be able to leverage and debug that existing code as well. So why don't I go ahead and actually start and set a breakpoint on the actual event handler for the, let's say, for the, I already have it actually, for the OK button in this case. So why don't I go ahead and start debugging this application. Again, this will launch the actual C# Windows form to begin with. Then we'll be able to actually step through from our managed code, which is quite amazing actually, into our native C++ code. So first thing, of course, the customer walks in and says, okay, I want to open up a new bank account. This is again actually calling the underlying C++ COM code. What type of then the user decides what type of transaction they want to do. In this case, we want to, let's say, deposit $1,000, for example. When I hit the OK button, as you can see right now, the language is, the actual call stack shows that we're debugging C# code, and I will keep stepping through this code right now. Now, notice just what happens. If you look at the call stack window again, we're actually debugging the physical C++, which is native code right now. And you can step again all the way through this code and then this will actually go back to your C# Windows Form application. And then if we actually continue executing this code, you'll notice that the actual current balance is set to $1,000. But again, it's important to remember that all the logic work was done by our C++ comp component. This was just very, very simple C# UI that I put up front, just to show you how easy it is to debug your existing C++ or other native components.
Now, would you have had to have compiled that ATL code within Visual Studio.NET, or could this have been an old code, old project you'd had before?
It actually, you don't need to actually recompile. That could have been, as long as we have the symbols, the debugging symbols, it's absolutely fine.
Okay.
So let me just go ahead and actually stop debugging right now. Now, I guess I've showed you a number of demos. We went through how to debug an ASP.NET web service, an ASP.NET web form, SQL stored procedures, and we just went through how to debug your existing code. The next thing that we want to look at is how do I go about instrumenting my code, which is a very, very important part of debugging, of course. Well, I'm really glad to tell you that the actual .NET framework provides an excellent framework that allows you to instrument as well as add tracing to your code.
What exactly do you mean by instrument?
Okay, so let's say, for example, that you had a web service and you didn't actually want to debug your actual web service by attaching a debugger to it. But you wanted to see what was happening within your code. Let's say, when were you opening a database connection? When were you getting exceptions? And you wanted to log this, let's say, to a file or to the Windows event log. It allows you to basically observe the behavior of your application at runtime. And then later on, you can use other tools to extract various information from the instrumentation code that you added. It's very much how you actually instrument hardware, I guess. That's how it works. So we use the same term when you're debugging software.
So would it be kind of like in a traditional, prior to even GUI-style application in C, where you have standard in, standard out, and standard error, you're attaching to standard error, and in your code, you're just dumping out lines to the standard error port and getting it once in a while?
Absolutely. But, the big difference, of course, is that the .NET framework support is just immense. There's an incredible amount of things that you can do, and unfortunately I'll be able to just show you that much of it, and there's a lot more, and I encourage everyone to actually have a look at it because it makes debugging your code that much more fun and easier. So I think the best way to show you how the instrumentation and tracing works is, again, to show you a demo. What I'm going to show you first off is how the actual tracing and instrumentation works for non-ASP.NET applications. So that's, for example, your Windows services, your Windows forms, as well as your, let's say, console applications or DLLs. So I should have a application here called Account Demo. That's right. Okay. Let me just go ahead and close this right now. The account demo is actually a C# console application. It's a very, very simple application. It's simply an account object, and I have various members, such as a constructor, and I can just show you. It's very simple. One other thing I should mention is that you noticed how I have these, I guess, regions. It makes coding that much easier because you can focus at a certain portion of your code at a time. So it's actually a very nice construct that we have in the IDE where you can expand and collapse certain regions. So if I wanted to, for example, just focus on my methods, I could either I can simply click on the plus button, and we're just looking at our methods and no other members. So what I would like to do, let me just go ahead and expand the entire object so you can see what's going on. Again, it's a very simple account object. It has a constructor, a default constructor. It has a single property, which returns the balance. And it has a couple of methods where you can deposit and withdraw an account. And the actual main application itself, all we do is we create an account and we deposit, let's say, $100. The question is, how do I actually go about adding tracing and instrumentation to this code? So again, I'll go back to my little cheat sheet right here, And if I look at the account demo, what we would like to do first is that we want to add some instrumentation to the deposit method. So why don't I go ahead and actually remove what we currently have, because I actually have written the code previously, drag and drop the deposit portion of it in here. And let me just go ahead and format the code. Now, let's see what's going on here. All I'm doing basically is that I'm using the trace object which is provided by the .NET framework to add tracing to my code. There's also the debug object, which has the exact same members. The only difference being is that these two objects are actually, their members are executed depending on whether you've defined certain conditional compilation constants. So in this case, if you actually look at your project properties, you'll find that under the build page, you have currently both the debug and trace conditional constants defined, which means that you'll be able to, these methods will be compiled in. What essentially a lot of people do with their methods is that they want to write when they've actually started their method, for example, output what the actual current parameters are, and a bit of text to show them that they actually finished the method. So why don't I go ahead and just run this application and see where that output appears. Notice that I'm not using any printfs.
But you are using write lines.
Yes. Okay, so... Oh, I'm sorry. Yep. As I mentioned before, I don't particularly trust my typing. Yeah. So that's why I have a lot of cut and paste code. Okay, let's just go ahead and see this. So I just went ahead and executed this. Now, if you look right here, this is where all the tracing and instrumentation output is actually displayed. You'll notice that the actual parameters output was indented. Mm-hmm. The great thing with that's actually part of the .NET framework, is that it provides an indent method where you can indent as many spaces as you want, so you can actually format your output, so it's much easier to parse or to read. Again, once I've done that, I've actually called the unindent method, which then unindents it, then I can write the end deposit. Now, the question comes, well, that's all nice, but what if I wanted to actually this output to go to a file, or let's say to Windows event log? How do I go about doing that? Again, the .NET framework provides a lot of support for that, and you can do that via configuration files, basically. So, the first thing that, of course, you want to do is that if you just leave your code as is, the problem is that when you actually deploy this code, this will execute all the time. And of course, what you ideally want to have is that you only want the code to output the actual text itself only when you want it to. For example, you've discovered the bug and you actually want to turn on tracing. And that's where, again, the .NET framework provides a lot of support with what they call switches. A switch, it's, I guess, essentially very much you can think of it as a light switch. You can turn it on or off, or there's actually more elaborate schemes where you can have multiple level switches. The idea of a switch is that it allows you to, I guess, control how much output and when the output is actually displayed. So let me just go ahead and show you how you add a switch to your current account class as it is. What I've got here is that I've declared a Boolean switch. Again, there are two pre-existing switches. There's actually the Boolean switch and there is the trace switch. I've declared a Boolean switch which I've named the account switch after the class name itself. And this is just some string for basically our consumption. Just tell you what the actual switch is for, basically. Now, the way you make use of this switch is that you will need to add some statements to your deposit method. Let me go ahead again. As I don't trust my typing skills, I've actually pre-canned this code in the toolbox. Again, I'll drag and drop, and I've made the same mistake here. Let me just go ahead and use the formatting option of the IDE, and I'll just format this code. Now let's just have a brief look at what's actually going on here. Now, there's actually an enabled property on the switch, on the Boolean switch, which basically tells it whether the switch is enabled or not. And depending on whether it's enabled, you can say output some instrumentation code or don't output some instrumentation text. There's also a variation of the write line method, which is the write line if, and you can specify a Boolean variable as the first parameter, and then that will decide whether you want to actually display the output or not. Now the question comes, okay, I've gone ahead and done that. You'll notice if I just run this now, there will be no text displayed. The reason being is that the actual account switch is not enabled. So let me just go ahead and run this code, and then as you will see in the output window, previously what you saw was the actual instrumentation text itself, but now you're not seeing anymore because by default the actual switch is disabled. Now, in order to enable this, you could do this via code, but a much more effective way is doing it via your application configuration file. If you haven't used your application configuration file, the idea is that settings which you can actually change at runtime or which you don't want to compile your code for, you can put those in an XML file, and then you can actually change the behavior application based on the settings in that XML file.
Without any recompiling at all?
Absolutely. That's exactly the whole intention.
So normally what you might do, but you might kind of back up to the code, find the constructor for the account switch, and just set it to be true or false dependingly. But then you'd have to recompile it on the fly if you needed to set things up.
Exactly. And that's the whole point of configuration files. So application configuration files are basically XML files. So let's just go ahead, and all we have to do in this case is add a new item, which will be an XML file in our case. You should be able to find it down here. Now, it's very important to remember, oops, that's an XSC file. There we are. Okay. It's very important to remember one thing. The actual runtime, when it loads up your application, looks for a particular naming on that file. So in this case, it has to be your actual application name, followed by the extension config. It's that specific. Otherwise, the actual runtime won't find it. Therefore, you won't be able to apply your settings.
So it's similar to the way that the manifest file works the exact same way.
Right, exactly. So why don't I go ahead, and if you remember looking at your Solution Explorer, the actual application name is called Account Demo, and then the extension it's an exe, and then it's actually config. This will just add an empty XML file right now, and without anything in it. In order to actually enable the switch right now, again, I've added some. I have some code from previously, and all I'll do is drag and drop the XML code that I had previously. This is very, very simple. All we're doing in this case is that we want to configure something in the system.diagnostics namespace. In this case, we want to configure a switch. The actual switch name is account. If I go back to the code, you'll notice when I actually declared the Boolean switch, I called it account switch. Therefore, I want to use the same name there. And a value of 1 means true, and 0 would mean false.
Okay, now before we move off this XML file, I mean, I can read through that, and it seems quite plain exactly what's going on there.
Right.
But I know next week, if I'm doing this code here, and I'm thinking I need a configuration file, oh, gee, what were those parameters called, and what was the formatting? So if I'm at that stage, where exactly would I find the documentation for the formatting of this configuration file? So
the actual .NET Frameworks team have documented all this in the Visual Studio.NET help. So you will be able to drill down. Actually, let's just have a look whether we can find that right now.
So I've done this often enough that it looks simple at the beginning, but later it's like, oh, shoot, where was that at?
Sure. So if I go to the actual help system for Visual Studio.NET and look at the actual index itself, let's see, we want to look for the system diagnostics element. Now, as you'll notice, this has been documented quite extensively. It describes the actual schema of the actual XML file itself, as well as it has a very comprehensive example of how to do this. So all I would recommend is that if you actually know, in this case we knew the was system.diagnostics, I just typed that in, and then in the actual index pane of help, and then we got the actual help for it. So all of the segments of the configuration file have been thoroughly documented in the help system itself.
Okay, thanks.
Sure. Okay, so we just declared a switch using our configuration file, and we've enabled it now. One caveat to remember is that if you look right now, the actual configuration file itself is under the, let me just go ahead and hide all the files to give you more of a view, is actually under the project directory itself. Now, when the actual runtime looks for the file, it looks right directly next to the exe itself.
So it'd be in the bin debug or bin release.
Exactly. Now, it's very important to remember, and I've actually spent quite a lot of hours tearing my hair out, wondering why my settings aren't being applied. So it's very important that you put this file right next to the actual assembly itself. So in this case, all I will do is I'll actually click on the Show All Files, which will display the hidden directories, which is in this case bin and object. Expand the debug directory, and all you have to do is simply grab the file and drag and drop.
Now, in a case where, like right now, so far all you've done is doing a build with debug options.
Yes.
If you switch to release, you'd have a second subdirectory called release, and you'd have to copy the file there as well.
Exactly, exactly. So it's very important to remember that if you do change your configurations or your directories, or you deploy your assembly to a certain directory, and you have certain settings in your configuration file, to remember that you want to make sure you have the configuration file right next to the assembly itself. So I believe if I just go ahead and save this file right now, everything should be set up. So if I rerun this application, you should be able to see the actual debugging output. And as you can see, we just enabled the actual switch via the application configuration file, and here's the actual output itself. And that's tremendous, basically, because it means you didn't have to recompile your application to enable the actual switch itself.
So in a case where, like, you had an application deployed out into the field and someone in the field called it the problem, you wouldn't have to ship them a new version of the application that might be kind of different, so you might not be able to trace the bug down. You just ship them a config file, they stick it in the right spot, they run it, and they can see the issues.
That is absolutely correct. That's exactly one of the points. And the last thing that I wanted to cover is that right now, all the outputs go into the output window. But as I mentioned before, let's say you want to output it to a log file, like a text file, or the actual Windows event log. Again, the .NET framework allows us to do that quite easily, actually. You can actually do that via what we call trace listeners. I guess the idea is that these trace listeners listen, if you will, for the actual tracing output, and then output it to the actual store that you specify. So the store could be the Windows event log, or it could be a text file, and so forth. Now, for this example, let's say that all I want to do is, instead of, or rather, in addition to the output going to the output window, I also wanted to display it in the console window that you usually display. So it's as simple as basically, so again, I've declared a very simple bit of code. And let's just see how this, once I format this. So I'm adding a new trace listener to the trace listeners collection, and I'm specifying the console.out as my store, I guess, in this case. So when I run this application now, you should be able to actually see the output in the console window. Let me just go ahead and set a breakpoint on the last statement to make sure that the actual console window doesn't disappear while we're trying to actually look at the output itself. So when I run this application now, hopefully you should be able to see the output in the console window itself. And as you can see, it's very, very simple to redirect your tracing output to another store. In this case, for example, the console window.
And you could have put that virtually any place. Written out to file, you could have had it automatically sent to you an email or something like that if that's the way you wanted to set
Absolutely. And again, actually, we recommend rather than you adding it in code as I just did, that you do it via the configuration file. It's very similar how you add a trace switch. So rather than me adding the actual console itself, for example, I could specify add it to a text file or add it to the Windows event log, for example.
So and you would have done that rather than adding, like we saw a Boolean switch getting added, you would have added a text switch or a string switch or something like that.
Right, it's actually very, very similar. I do have the bit of code, XML code that shows you how to do that if you like. So if we go back to our configuration file again, it's again in the same configuration file. I believe I have the account listener, yes. And I may have to change that a bit, yeah. So it's very much like how I did before. Again, in the system diagnostics namespace, in this case, you can actually tell, I guess, the diagnostics APIs to automatically flush to the actual store itself and not keep it in memory so that the actual output goes to the store itself. Mm-hmm. You can also specify the indent size. Again, if you remember, the indenting and unindenting, you can tell it how many spaces to move. Again, in this case, I've added an account listener, and I would like it to go to a file called account.log.
Oh, I see. So this takes the total place of that one line of code you added in there. So you don't even have to have an add of a generic thing. You're doing the add directly here in
Absolutely.
XML.
Yes, it's as simple as that, basically. So it's very, very convenient. And if I set this up by moving the actual code into the above parameters, you'll see that there'll be a account.log created under the, again, bin debug directory, and it'll display the exact same output as you saw here. So it's very, very convenient to actually add a listener to the to your code. One last topic that I'd like to talk about is actually asserts, which is very, very important, again, as part of your debugging. Again, you can access the assert APIs via the .NET framework. So in this case, let's say, for example, I wanted to add a lot of assertions, for example. I really do like assertions, so I usually I go a bit overboard with assertions. So I wanted to add a lot of assertions to withdraw method itself. So in this case, let's see what that looks like.
You do like asserts, don't you?
Yes, I do like asserts. So I have basically almost catered for every single possible thing that could go wrong. I'm basically checking, is the amount greater than 0? A non-negative account doesn't make sense. If it is, then display amount is less than 0 and actually throw up an assert. Then I actually handle the actual case by throwing an exception in this case. There should be no overdraft, basically. The balance itself minus the amount should be greater or equal to 0, of course. These are basically, I guess, what you call your preconditions. These are the conditions that must be satisfied when you enter your code. And of course, I like to add a bit of post conditions. So I like to make sure that all the work that we did within there, make sure that the actual balance is positive. And then I'll output a bit of text saying critical error. The actual post condition was violated. So, and as you can see, there's just a tremendous wealth of tools, both in terms of Visual Studio.NET Debugger and the .NET Framework APIs that allow you to basically debug your application any way that you feel comfortable with. So I guess it's really like up to you to figure out how much of it you want to use. But I would highly recommend, it's like any tool. The more comfortable you are with the tool, I think the more uses you'll find and the better use there is for it, basically.
Well, thanks. Now, if someone in our audience really wants to get into debug even more than we showed here, because obviously we didn't show everything you could possibly do with debugging.
Absolutely. There's just a tremendous wealth of, there's just not enough time, I guess.
What are some good resources you'd recommend someone checks out for finding out more about debugging an application with VS.NET?
I think the best and foremost source is, of course, the documentation. We've made sure that we have a pretty good documentation set in this version of Visual Studio.NET. There are a number of great articles on MSDN. I think they're very worthwhile, especially with tracing and instrumentation as well. As well, I believe there are currently a number of books being printed purely on debugging.NET applications. So there are various other avenues. Of course, there's also the MSDN, various other news groups as well that you can join. And actually, you'll probably see me on those news groups quite frequently. So I'll be more than happy if you're on those news groups, if you have questions. Yeah, I'm more than happy to help, basically.
Just so long as no one in the news groups ever gives any hassle about never watching Star Wars, right?
That's absolutely true, yes.
So remember, don't give Abib any trouble about never having watched Star Wars before, even though he hasn't, but, one of these days.
Thanks for that, Robert. I guess the reason is I've actually never watched any Star Wars episodes, and I guess get quite a lot of grief at work because everyone, of course, watches Star Wars, and it's like, well, you actually have never seen a Star Wars episode? And I say, no. I guess my point is I don't really understand what the point of the show is.
Of course, now it's more of a badge of honor. So now you can't watch Star Wars now because they don't know they give you hassle about it.
Exactly.
Well, thanks, Abib. I'll make sure I get those links that you mentioned onto the bottom of the transcript so people can get access to those real easily, as well as anything else that you think you might be able to provide as a resource. I'll include those in the transcript as well. And so hopefully now you've taken and got some good insights on how Visual Studio.NET can assist you in your debugging efforts while you're writing .NET applications. Thanks for joining us.
An essential part of the product design process at Microsoft is the Microsoft Usability Group, which gathers user feedback through several forms of research. And with me today is Amy Alberts. She is a usability engineer at Microsoft. Amy, welcome.
Thank you.
Thanks for joining me.
Thank you.
Why don't you tell us a little bit about the Microsoft Usability Group and what you do for them specifically?
Okay. Microsoft Usability is actually quite a large group. There's about 150 of us that work across all products on Microsoft.com. So MSN, Microsoft.com, the specific products like Office, you name it. Pretty much anything we produce has usability engineering touching it at one point or another. I specifically work on Microsoft.com. There's 5 usability engineers, and it is, I specifically work on the Download Center, search, and the commerce part of Microsoft.com. So,
what sort of tests do you run?
We do a number of different types of tests. It ranges from field research, where we go out into the field and watch users use Microsoft.com and see how we facilitate in their use of the site, how we facilitate getting their job done. We also bring users into the labs and run actual just scientific studies on the particular websites that we work on. So we'll bring users in to do a number of tasks on search or come and work on the Download Center to ensure that not only are our products you can use them, but also that they're useful. So those are our 2 main goals as usability engineers.
So how much of the results affect the actual product design, or when do you get involved in the process when usability would be used?
Best case scenarios is that usability comes in very early in the product cycle. We can affect everything from product development to the actual point of the UI getting shipped out onto the web. The best case scenario, of course, is that we are involved the whole way. And so our findings from field research will help inform the new features that we need to have on the Download Center, for instance. Or research later on in the process when we are prototyping the UI. So we have a new concept around how we want users to search. So we'll bring users in and it'll just be wireframe, like pieces of paper. And okay, what do you think of this? What do you expect to be right here if you were to click on this button? And then as we get farther along in the UI process where it's actually working and there may be still some bugs, but the point is to bring users in and have them do the typical tasks we want to support. Bring them into the lab. We have a really high-tech lab set up, which is really great. And users come in for 2 hours and perform tasks on the sites, and we watch them and intervene as little as possible, and then we make recommendations back to the teams as to what needs to be changed.
So what sort of background do you need to do usability?
It's varied. It's very varied from what I could gather. I didn't actually study to be a usability engineer. But the fields that are very applicable to usability engineering is specifically HCI, so human-computer interaction. Human factors engineering is kind of the grandfather of usability. I have a degree in applied cognitive psychology, so that is the most applicable of the very academic, non-applied degrees that you can have that is really appropriate to usability engineering. So, but I mean, there's anthropologists, people have really varied backgrounds. It's really a matter of, are you a scientist? Are you interested in the entire product cycle? Are you interested in technology? Those are three major things that influence if you can be a good usability engineer at Microsoft.
And did you work in the psychology world before Microsoft at all?
To a degree, I taught for about 4 years. I taught at Ripon College. That was my alma mater. I taught Freud and scientific methods and statistics. And then my graduate work also included grant work, so I was working in that as well. So I was at least in the academia.
Mm-hmm. What was your specific course of study, the specific research you did for your graduate degree?
My research was on psychophysics, which is not a term many people use, but is actually one of the first things you learn as an intro psych student. And what it was specifically were eye movement measures of prior exposure to objects. And it was a measure of the human memory system, and basically that the memory system is located in the brain in the hippocampus. But there are certain memory effects that express themselves in overt behavior. And it's been the interest of psychologists for years to figure out how can we look at just overt behavior and understand what's going on in the inside. You know, that's clinical psychology. That's what psychology in many ways is about. And so what through years of research, they were able to determine that eye movements, very specific eye movements, are indicative of prior exposure or of memory. And so my work was to expand on work that was done at the University of Illinois Champaign-Urbana on the eye movement recognition patterns as they relate to human faces. So being able to tell if somebody had seen or knows somebody via eye movements. And so my work was specifically to generalize that effect to objects. So to be able to show a picture of something and a human being being able to use their eye movements to be able to measure whether or not they had seen it before.
So what are some of the applications of that type of research? Where could that be used?
There's basic memory research applications where we can really understand a lot about the evolution of the brain via understanding memory systems. And so that's one of its first applications. Also, there's a lot of, like, amnesics. Somebody who's a severe amnesic isn't able to recognize anything, has no overt memory, no express memory of anything. What's interesting is the eye movements are actually indicative of memory. So I can take a total amnesic, they have no idea they can't even recognize a picture of their own face, and show them pictures of things that we know that they have seen, and their eye movements will show that they have been exposed to that stimuli. So that's a huge for really kind of a clinical aspect. But then there's also the side of being able to know if somebody has seen something before or not. It's not a leap to assume that this can be applied in law enforcement. And so somebody says, a lineup, for example. Instead of asking somebody, have you seen any of these people before, we can just look at their eye movements and know who of those people that person actually had contact with.
Wow.
It's really interesting.
Fascinating.
It is, especially because a lot of times work in the academia goes by and nobody ever really does anything with it. And so this particular line of research is only available because of technology. I remember I counted for my thesis the number of data points I have, and it was 357,000 data points. You couldn't do that before computers, And so now we have the technology in eye tracking and in computing and statistics to be able to handle that kind of data set and actually do something good with it.
So what sort of things do you like to do outside of work? What are your hobbies?
I enjoy art a lot. I actually studied art when I was in undergrad, so I'm not an artist by any stretch of the imagination, but I enjoy collecting art. I'm particularly interested in Art Deco and in modern art. So There actually isn't a lot of Art Deco or modern art in the Northwest that I've been able to find, so it's one you have to look for it. But usually, if people aren't interested in it, you can find a good buy here and there for great pieces of vintage deco or modern art. And outside of that, because I have gone to school, I went to school undergrad in Wisconsin, and then graduate school in Montana, I spent a lot of time just keeping in touch with friends and family that are kind of scattered all over the country.
So you're interested in art. I want to get back to that. Who are some of your favorite artists?
Of the classics, I guess for me it's classic art history. If you study too much of it, you can't ever answer that question. And there are a lot of classic periods that I really like, but specifically in the whole Art Deco genre, I really like Klimt, Egon Schiele, a lot of their names I can't remember right now. I enjoy Andy Warhol a lot. So those are, what's interesting is that I think I'm jaded now, or I can't really enjoy really modern art, like the stuff that's coming out right now, because I'm still so interested in the movements that happened before. So, but I am very interested in those. I had a long stint of being really interested in the pre-Raphaelite Brotherhood, which was a group of artists, there was like 13 of them, who decided that no art was good after Raphael. So their whole line of work was all dedicated to stuff that looked like Raphael's work. So I changed my mind about everything. So
do you find you're generally able to balance your interest in art, which traditionally is more right brain, and your work here at Microsoft with traditionally technology is more left brain?
Yeah, I think it's one of the few jobs that I could have really try to strike a balance between those things. There is something to be said for making something aesthetically pleasing. And it's difficult. There are times where something that's aesthetically pleasing isn't useful or isn't usable. But I do believe that there is a balance to be struck. And I think that's something that we strive for, at least on Microsoft.com. The designers that I work with and the usability engineers and the PMs, everybody, even the devs, there's an art behind it because it's innovation, and innovation is art. So I think that I find I can get out of the process that Microsoft goes through in trying to be cutting edge, get from that some sort of satisfaction and, filling that void of art, that is difficult to see when you're among, a bunch of processors, and art is, difficult to find. So, but I do think it's there.
So where do you think the Microsoft usability group is heading towards? Any changes you see in the future of how we'll study products?
I don't think the method of study is going to change so much as the influence that usability is going to have. With recently, Bill basically talked about the need for security and to ensure that our users and our, just all of our consumers feel a sense of security in using our products. And there is the back-end security, that the developers do that ensure that our products are able to withstand negative things, hackers or whatever. I don't really understand a lot of the security stuff. But there's also the front-end side of it, to be able to display information to users that looks secure, that they can use a UI that they can ensure its security. And so we have two usability engineers on Microsoft.com that have a history of evaluating UI and software in terms of user perception of its security. And so that, and there's other usability engineers across the company that specialize in that. So, and it's so important, for us to build, to be useful is to ensure that a user uses it right. And that's a fundamental thing that you need to do to ensure security, is that people are using things right.
Right.
So I think that's going to be a major focus down the line.
Well, Amy, this has been great information. Thanks for joining me today.
Thank you. I had a great time.
Great.
Well, that brings us to the end of another episode of the .NET Show. We hope you learned some things about how to debug your applications using Visual Studio.NET.
And stay tuned for the next episode where we'll talk about the Mobile Internet Toolkit.
And until then, we'll see you on the web.